All right, folks, once again, good afternoon. Thank you for joining. We're glad everybody was able to take some time and join in this conversation today, where our focus will be specific to how manufacturing personnel can help increase the value you as a supplier bring to your customers. If you have any questions along the way, you'll be able to enter them into the message box and we'll address them at the end of the presentation. If you're unable to hear us at any given time, please type in into the same message box and we'll try to resolve that as quickly as possible. And we're about to get underway. So I'm Shawshank. I'm one of the account managers here at Aventec. And today, my next hour will be dedicated to listening to and watching everything Zane shows and says. As a product specialist, Zane spends his days looking at problems that occur in day-to-day operations and connecting the dots to see how the process may be contributing to issues in your day-to-day life. Because of the extended focus and study, we're able to discuss openly how manufacturers who might be struggling with some on-time delivery, quality, or a plateauing or decline of customers can better invest their time and money if they augmented their point of view. And today, that point of view is through the eyes of the manufacturing engineers. A couple of years ago now, the number of new flyers was on the rise, especially from the Asia market and the Africa market. Now, you have to just look at what that means from the OEM's perspective. If there are more flyers, that doesn't necessarily trickle into just more airplanes. It means more frequent maintenance. It means parts need to last longer to avoid too many maintenance holes. It means the pressure on every single part that is critical to the system is also higher. And if there are any defects, reworks, recalls, or retrofits, that process needs to now be managed on a much larger scale. So while people want to travel faster, safer, and more comfortably, so should suppliers want to deliver faster, safer, and more comfortably. Now, the aerospace industry is considered one of the slower ones as far as product innovations are concerned, with new designs taking maybe 10 to 30 years to develop. The automotive and medical device industries, tool making industries, however, they operate on a much more accelerated tempo and a much higher direct impact to daily consumers. So the pressure to be right and fast is that much higher. Now, in a study that Dassault conducted, they found that while OEMs in most industries like to control their supply chain relationships based on cost and deliveries, the price pressure from the consumer is trickling down directly to the supplier. This means, as a supplier, if you're going to command a certain price, your customer doesn't just want the part or widget or service or device for that price. They want more than that. They want guarantees. They want a sense of security that with you as their supplier, they will be able to maintain and grow their consumer base and their brand loyalty. And that's why OEMs are becoming very open to suppliers who focus on introducing innovation within their companies, not just in parts they manufacture or produce, but also the way they produce these parts, the way their product is handled. This white glove service expectation will soon become the standard in all manufacturing industries, where the supplier that's able to provide this while consistently finding ways to cut costs will pull the industry with them. And in an economy where OEMs are outsourcing nearly all of their manufacturing and strictly focusing on their role as an integrator or aggregator, this means that the number of suppliers will increase as well. The flip side is the suppliers that don't, they won't necessarily go out of business, but they will be forced by the industry to adapt when the cost to adapt becomes significantly higher. And that's why today's focus is on challenges manufacturing engineers are facing on a day-to-day basis. And our hope is that by the end of this talk, you'll be able to see a version of how things could be done on a granular level. On a daily task level, a lot of times the strategy and tactics that you hear in leadership announcements really trickle down to a shift in how you do things on a daily basis. And if you're in leadership or you're evaluating leadership, the key litmus test is to see whether the daily priorities and the things you spend time on every single day are aligned with what the message is to the entire company. Now, while the product we'll discuss, it is more aerospace centric, that challenge applies to pretty much any product that's being manufactured. And after speaking to a few engineers and even from our own professional experiences, one common thread that we find that exists everywhere is this extreme reliance on custom-made tools for each task. Comparing a bill of materials to a previous version, create an Excel file. Want to see how a new process will affect cycle time? Create an Excel file. Want to make revisions to a process plan? Create a document, then PDF it, then email it or print it for approvals, then save it, then catalog it. You get the idea. Companies rely on systems to get things done in a predictable way. And even at an individual level, creating an Excel file is creating a system. And today, companies, even the smallest suppliers, have between hundreds to thousands, even more of these little systems here and there that do very specific things. What this leads to is multiple people relying on relatively similar systems, but with minor tweaks and variations to accommodate their own nuanced needs, all stored in different places. That's like having 1,000 grocery list variances in 1,000 drawers throughout the entire neighborhood. Now, the goal is the same. We all need groceries, and you, as the company, needs to deliver parts. When you become reliant on these disconnected systems, now the breakdown of communication results in duplications, comparisons, manual error checking, manual guessing, extreme reconnaissance of emails, files, and people to troubleshoot even the simplest problems. Now, even in a small place like a highway side restaurant, if communication breaks down in the kitchen and front end staff, it results in chaos almost immediately. In conditions that we have today, where people are getting used to having things yesterday, you cannot let the simplest tasks like communication, error checking, excessive checking, waiting for approvals, long status meetings, you can't let these get in the way of you being on time. Think of the last time your Amazon Prime or whatever service you use, think of that package that it wasn't there by 9 p.m. That anxiety you feel when now it's 10 p.m. and those $100 or whatever you spent on getting same day service becomes the sole reason that you're infuriated. What a waste. It's not even here, and it promised same day delivery. Now imagine your customers waiting on parts. Imagine your customers waiting for answers. Imagine your customers just waiting. Manufacturing is a complex orchestra of different instruments that have to be tuned and timed just right to hear something even reasonably resembling a decent sound. But mistime even one instrument, and it all breaks down. And now Zane will walk us through an example of how a manufacturing engineer or process planner or plant engineer or anybody in the manufacturing ecosystem can play their part just right.
Awesome. Thanks, Shashank. And hi, everyone. This is Zane. Okay, so for this demonstration we have planned for you today, we'll walk you through quite an extensive portion of a product's lifecycle. Now, the tool or the kind of models that we'll be using are mocked-up models, which represent several stages of a product's lifecycle. They are simplified just so that we can demonstrate things in simple terms. So just a heads up not to take these models themselves literally, but rather grasp the core ideas supporting the various concepts that we want to convey. Okay, with that said, let's jump right in and get started. So in this demonstration, I'm going to be walking through the process of updating the manufacturing bill of material, or MBOM. We'll be creating a process plan from this MBOM. We'll validate the process plan, and we'll wrap this all up by developing the work instructions from that plan. Now, the activities that I've just described, they're typically performed by manufacturing engineers, as Shashank already mentioned, in various industries. Now, this could be a single engineer, or it could be a team of engineers working collaboratively to perform these tasks. It really just depends on the size of the company and the workload demand. So because of that, we decided to call this demo a day in the life of a manufacturing engineer. But before we begin or jump into the demonstration itself, I just want to add some context by briefly describing some of the steps that I'll be showing. So say I'm a manufacturing engineer working for XYZ company, and my typical day involves me working closely with various design engineering teams and various shop floor teams in order to make our company's product manufacturing ready so that it can be manufactured in the most efficient and economic way possible. So if I were to break that a bit down, a bit more, what would that look like exactly? So design engineering would release the CAD product structure, which would include the final product's assemblies and sub-assemblies, and the list of parts or components that make up these assemblies. So my first task as a manufacturing engineer would be to develop a manufacturing bill of materials using this CAD structure. Now the MBOM itself would be made up of all the parts and assemblies included in the CAD model, but also any additional elements required to build a complete and shippable product. So for example, this could include items such as, say, the adhesives used to mate two parts together, or it could be the packaging material that my product would be enclosed in. Essentially all the items that are included in that final product that I'm going to be delivering to my customer. Additionally, the MBOM would be structured in the order the assembly operations would take place, reflecting the way the product will be manufactured. So once I've completed developing my MBOM, I would use this MBOM to develop a process plan. And in the process plan, there are a variety of things that I would define, such as all the tasks and activities required to manufacture this product, in what sequence those tasks would be carried out, if the appropriate resources are provided to carry out those tasks, what's the overall cycle time required to manufacture this product, and the list could go on. And once I've created that process plan, I would also validate and test it to see if it is the most effective solution that exists. So as the process plan is being developed, I can also concurrently develop the necessary work instructions to support the various processes. And these work instructions would contain all the detailed descriptions of how to perform a task within the process. For example, if my process plan contains an assembly task for assembling two sub-assemblies together, my work instruction would actually go into the detailed steps of describing those two sub-assemblies and how they're going to be assembled together. Essentially, these work instructions are the documentation that will be consumed on our shop floor by our operators and technicians in order for them to do their jobs. So now that I've walked through, let's say a crude summary of the various activities involved, let's just jump right into the environment so I can show you what these various deliverables of these activities would look like already set up. Okay, so I've just jumped into the environment, and if you take a look at the top left corner of the window, you'll see that I have already opened up my landing gear assembly, which is going to be the product that I'll be using for this demo. And the structure itself is located within my specification tree under my root PPR context. Now the PPR context element will contain everything from my assembly, my MBOM, my process plan, my resources, which I've defined for my project. And you can observe that I already have an item for each listed under my PPR context. All right. So what I'm going to do now is do a quick visual interrogation for some of these items so that I can see how everything is structured or laid out. And we'll start with the plant layout, where I can see how my resources are defined for my landing gear assembly cell, including the shop floor technicians that'll be assembling the landing gear, the overhead crane right there, which will be used to move the heavy parts. We also have an AGV that'll be used to transport the product. So quite a bit defined there. Next, let's look at the MBOM. We'll just switch over to the manufacturing item definition app. And we're just going to do a quick visual inspection of all the parts that make up our final product, just to see how everything's laid out. All right. Next, let's take a look at the process plan to observe the sequence of activities or operations that will take place to assemble the product. All right, that looks about right. Okay, so we've quickly interrogated our current PPR context, and I think we're ready to bring up the challenge of the day. So I've just been informed by our design engineering teams that some changes have been made to our landing gear assembly, and that a new part, in this case an actuator, which we'll be bringing in, has been included in the assembly, and that we need to prove and implement this change request rapidly, and also validate if we're still able to assemble our product within a requested target time. So let's jump back into the environment. And the first thing I'm going to do is quickly instantiate a new actuator part into my CAD's assembly design. So let's do that. I'm going to use our platform's search capabilities to quickly locate that actuator part. See right there. Now let's just bring it in. Okay. All right. So next what I'll do is I'll add some quick constraints to correctly position this new part within my assembly. And let's just say that is sufficient. Okay, so now that we've made some changes to my CAD assembly, I now need to update my MBOM to reflect these changes. So I'm going to switch over to the manufacturing item definition app where I can do that. All right, and the first thing I'm going to do is quickly expand my root manufacturing item so that I can see where my new actuator part needs to be included within my MBOM. Now there are several assistive tools that I can use to help me develop my new MBOM. Specifically, I'm going to be using the BI Essentials tool, which I've just opened, and I'm using this to help show me which items from my CAD have currently not been consumed within my MBOM. So if you take a look at the legend within the BI Essentials tool window, you see that everything in orange is currently not assigned in my MBOM. And if I were to look at my specification tree, at my CAD's product structure, I see color indicators next to each item's name, and we can see that the new actuator part is currently showing as orange, indicating that it still needs to be included within my MBOM. All right. So next, what I'm going to do is create a new manufacturing item for this actuator within my MBOM. It's a new item right there. Just quickly rename it. And what I'm going to do is I'm going to drag and drop the actuator part directly into this new manufacturing item. And the second I drop the part into my manufacturing item tile, you see that visualization of that part showing up in that tile. And now if you take a look at the same color indicator in my specification tree, you'll notice that it has turned blue, indicating that the part has now been consumed by my MBOM. Now, granted, this is a fairly straightforward MBOM change that we made, but in cases where I'm working with more complex product, there are additional assistive tools that I frequently use called 3D View. And I'm going to open that tool up. And this tool helps me visually interrogate my manufacturing item that I have and cycle through items in my CAD's product structure so that I can get a better idea of where each item is included in my product. All right. So I think we've made all the changes required within the MBOM, so we should be good to move forward at this point. So now that the MBOM has been updated, I'll need to update my process plan. So we're going to switch over to the process planning app where I can make those changes. All right. And similar to how I updated my MBOM, I will be updating this process plan. So notice how the look and feel of this app is similar to my manufacturing item definition app. So this consistency also makes it easier for me to work with these different apps. And similar to my MBOM app, I'm also going to be using those same assistive tools. So in this case, the BI Essentials tool and 3D View tool, but this time to help me determine which items from my MBOM still need to be consumed in my process plan. So let's do a quick inspection of my process. And I've located the system within which I need to create some operations for the actuator assembly. And I'm going to be using the manufacturing system Gantt tool to help me determine where I want to sequence these new operations. I'll still use the 3D View tool just to see what each tile contains and see the sequence of how these parts are coming together. Looks good. All right. So what I'm going to do is create two operations for my actuator. And the first operation will be to load the actuator part. So if you want to visualize this, this would be an operation where our shop floor technician spends time retrieving the part from, say, a storage location and loading it. And I'll create a second operation for the actual assembling of the part to our product. Things around. Next, I'm going to define the product flow and add any operation precedence constraint if required. So this is how the assembly operations will take place, the sequencing. One more, and that looks good. And let's just wrap this up by doing a quick check of the operations in my process plan by once again using the Gantt chart. We'll just resequence some of these things. A nice waterfall operation sequence right there. Check it out for my entire system. Okay, so now that we've updated our process plan, next we need to validate the plan and check the impact these changes that we've made have to our overall cycle time. And we can also do a takt time analysis to determine if we still are able to meet the demand for this product. So I'm going to switch over to the factory flow simulation app, which I'm going to be using to do this analysis and generate some simulated data for my process. And this simulated data will help me make more informed decisions of any adjustments that I need to, that may be required to our process plan. So note that I've currently not made any changes within this environment. And what I'm going to do first is we're going to start by running the simulation as is, so that I can generate some benchmark data of my process and so that down the line I have something to compare my changes to. In this case, we'll do a quick discrete event simulation. All right. And while this simulation is running, I'm also going to open up my states history tool and quickly glance at the current states of all the various resources that are currently working within my environment. So looking at this fairly colorful chart, I'm going to explain the color scheme I used here quickly. If I observe the bottom of the chart, I see two technicians and the overhead crane currently in work. The green color indicates when the resources are performing the tasks, while the yellow indicates that these resources are standing by idle. All right. And if I were to scroll down this window, I should see two additional technician resources that I've allocated to station 1 in my manufacturing cell where the final landing gear assembly is taking place. And I can see that there is quite a bit of idle time between both of them. So this tells me I definitely need to reallocate the activities of these resources a lot more efficiently. Okay, so I'm going to speed up the simulation so I can get at least 2 cycle time worth of data to compare to. And that was done quite quickly. And I'm going to pull up the simulation data generated at station 1. Now there's a whole lot of information to consume in these tables, but to keep things simple, I'm going to quickly scroll down to the operations section and take a glance at the processing time or duration for those various operations that I had defined in my process plan, and also the required times that I can getting from the simulation itself. So you can observe for all my operations, I had just left my default time of 10 seconds for everything. Granted, I know it's a bit unrealistic, but notice how the requirement time column is showing me times of 2 to 3 times higher for the various loading operations taking place. So that's definitely something I should consider updating within my process plan. Also, the simulation will help me determine any potential points where backlogs may be occurring within my process flow, which I may also need to address. All right, so next we're going to scroll down this table, and I see my cycle time table, which is giving me the minimum, maximum, and average time that it took to simulate 2 cycles for my product. And of course, if I had run the simulation over a longer time frame, the more this data would start to converge to more accurate values. But for now, let's just say that these 2 cycles should be sufficient. So I'm going to export this last table to an Excel sheet so that I can use it as a benchmark later on. All right. All right, so now that I have some benchmark data for my old process, I'm going to update my actual factory flow simulation to account for the new actuator part and operations associated to it. All right. So the first thing I'm going to do, I'm going to start by creating an inflow for the part into my environment. So this is actually bringing in my actuator part into my simulation. Once again, I can use my specification tree to grab that part directly from my MBOM. All right, I also have a resource bin already there within my simulation. I know it's not being used for anything. So I'll also need to add the product flow of how this part will be moving through my manufacturing cell. Right. Just set the capacity of how many parts can this bin hold. And that should be sufficient. All right, so next I'm going to assign the new operations that I created for the actuator to the station where those operations will be performed. So in this case, that's station 1. I'm just going to locate it. And once again, this is as simple as dragging and dropping the operations from my process plan in my specification tree into my simulation where those activities will be performed. All right, there you go. Okay. One thing I'll also need to do, I'll need to resynchronize my other activities since I did make changes to my process plan. So just to have the up-to-date names, times, precedence, links, etc. From my other app, from my process plan being considered in this simulation. Now that that's done, I'm going to use some of the same assistive tools I used in the other apps. So in this case, the BI Essentials tool, in order to help me validate that my factory flow is set up correctly and that I'm good to run the simulation. It's always good to do these checks, and most of it's showing up good. So I do see a bit of an error over there. And investigate that a bit further. All right, so some of these warnings can be ignored. but in my case, there does seem to be a missing product flow path required for my actuator part to station 1, and the tool has brought this up to my attention. So, actually, what I'm going to do is create that missing flow in order to remove this error. And I'll also arbitrarily assign a resource from station 1 to perform the loading operation for the actuator. And this should be sufficient for our simulation. Going down, I see the actuator activities showing up as green, so should be good. Okay. All right, so now that my simulation is all set up, I'm going to run my simulation, and I'll just, fast forward it so it once again completes at least 2 cycles for this product. Granted, it's a tad bit unrealistic with the people actually holding the tires and moving them. Okay, so if I zoom in, you can see that the new actuator part's actually showing up in my simulation, so everything looks good up till now. So not much change to my state's history. Still quite a bit of idle time here. All right. Okay, so now that 2 cycles have been completed, let's take a look at the simulated data generated for stations 1. And I can see, scroll down, in my operations table, that the actuator loading operation is now included, and the simulated requirement time is around 23 seconds. Right, so quite high. So if I were to scroll down even further back to my cycle time table, I'm going to once again export this table to an Excel sheet. And taking a look at that benchmark data, I see that my average cycle time has actually increased by approximately 20 seconds. So definitely something to consider. But I also know that the resources that I have at station 1 that are performing the actuator loading and assembly operations had a lot of idle time. So definitely quite a few areas of improvement that I can make in order to better my process and flow, and possibly even decrease my overall cycle time to values lower than my benchmark. All right. Okay, so say I've obtained the necessary data that I need to make a more informed decision on how to improve my process plan. So now what we can do next is go back to our process plan and make the changes needed. So let's do that. I'm just going to quickly do some, let's just say a duration change for one of my activities. And for argument's sake, let's just say that is sufficient. We've done our job. And now that my process plan is complete, the next thing, the last step we're going to do is update the work instructions documentation so that we can push these new manufacturing instructions to the shop floor. So I'm going to go into the work instructions app. And the first thing I'm going to do is find the various operations that I created for my actuator. So actually locate the system so that I can create the necessary work instructions for them. Now that I've located the system, I'm just going to cycle through some of these items. Okay, so I've located my loading and assembly operations. So let me quickly create some instructions for each. So the first one, which was the loading activity. So we're going to load it from some arbitrary bin number. Let's put the second activity, which was the assembling activity. let's just say this actuator needs to be assembled at location 6. I'm also going to create a quick view of where location 6 is. Okay. All right. That should be good. So now that I've updated my work instructions, what I'm going to do is I'm going to generate my work instructions report just so I can validate that the updates, all the updates that I made. There's a quick report script I'm going to run. Once again, locate the system where these operations are being performed. And I have my 2 operations right here with the view that I had created. Okay, so now that I've updated my work instructions, I think I'm ready to push these work instructions forward to the teams on the shop floor that will be consuming it, and this will enable them to work efficiently to perform this change request. All right, so just to summarize some of the things that we went through in this demo, we received a change request from engineering, which prompted us to make changes to our MBOM. We changed our process plan, we validated the changes to our process plan, and finally we updated our work instructions. Now the key point being that we managed to do all these activities and responded to this change request quickly and seamlessly with the help of several assistive tools, all within a single platform that helped us easily transition from one job to the next. We also saw that there is a certain consistency in the look and feel of the environment and the tools that we used, and this makes things a lot more intuitive, makes things a lot more fast, and there isn't much room to make mistakes. Now, the one thing I would like to point out is that many of the activities that we demonstrated tend to be done within teams, actually among several team members, and that the environment allows us to collaborate in context in that way. So say while one team member is developing the process plan and another can actually be working on the work instructions. And this helps us to effectively execute work within our company, you know, in between our departments or with our customers around the world. Anyway, so clearly I didn't spend the entire day doing this, so maybe we should change the title of this demonstration and call it 40 minutes in the life of a manufacturing engineer to be more accurate. What do you think, Shashank?
Definitely.
Yeah.
And if I can reduce the amount of time I spend on things by such huge factors, I see this as an absolute win.
Yeah.
Now, what you've seen here is a short example of how tasks that help move material from unprocessed to process to finish. The subtext of it is that I hope you've also seen that how value-added tasks in your operations at all levels can be separated from those that don't add value or essentially become wasted time. After digging deeper, by observing operations at a typical mid-sized to large supplier, we observed that between 8 to 35% of the time spent on day-to-day operations is obviously not adding any value to producing the part and meeting the production readiness and deadlines. So think about that on an hourly basis. If you had the dollar value for each hour you spend on tasks that don't add value, how much will you spend that you could avoid? This philosophy of the lean production system that was pioneered by Taiichi Ohno, who's the creator of the system at Toyota, it's really come into its elements today. And if you're able to avoid that cost of waste, you should make every effort to do so. For any company to succeed, even in this mock-up scenario, you've seen the foundations of how the 3 key axes of your company's success integrate so critically. The most important is you, the people. What you've seen is something that either multiple people do in your company or just one person, depending on how you divide up tasks, but the people doing the tasks are still the most critical element. Then how your time is spent and how it can be spent to improve the how of your company. That's the process. And finally, at a tactical level, the tools you use. whether they allow not just you, the manufacturing engineer or shop floor technician or the VP to complete your tasks, but do they allow everyone in your company to do what they're supposed to do well? The result of doing things in this way by integrating all three key axes is that any activity that requires checking, verification, completeness checking, property checking, anything that's manually labor intensive can be done without introducing things that are simply a waste of time and effort. Anything that is a non-value added task that you might not even realize it should be taken away. The other result of doing this is that you become robust enough to take on any challenge because your process has been mapped and constructed. Any inefficiencies coming from waiting, errors, transportation of documents, approvals, and release procedures is eliminated right away. Furthermore, you can try out new ideas of how to set up your line and see the impact of your manufacturing decisions right away. I want to thank everyone for staying with us till the end. And as we prepare to take questions, here are some questions that I would consider. If you could make one change in your processes, what data are you using to come to that conclusion? How are all the people involved in making that decision and conclusion contributing and collaborating? And if things are in fact going well so far, and we're happy to hear that, how long will you be able to sustain your current way of doing things? At this time, if anybody has any questions, please feel free to type them in the chat window and we'll be addressing them as they come in. Okay, it looks like there aren't many questions. Well, in that case, that's it for this demonstration today. I hope it was informative and that you enjoyed it. If you do feel that you have some question you would like to talk to us privately, or something you'd like to inquire about, or even have ideas for future things that you'd like to see, we'd love to hear from you. So feel free to shoot us an email at info@aventec.com. Or you can follow us on LinkedIn to see more current content that we release regularly. Now, before we say goodbye today, we've got an announcement to make. Now, we haven't decided when yet, but we are launching a second part of this webinar that will focus on the latter tasks and operations after the work instructions are done. Once you have the work instructions, you then have to go about planning the production for your upcoming quarter, depending on how you like to plan things. You want to make sure you have the right amount of inventory and personnel, and everything is in place to make sure you can deliver those parts. And then there's a day-to-day scheduling of these jobs to reflect how things are changing and to capture the finite capacities of your resources to make sure that if a machine goes down, you're still able to meet that deadline. We will be interviewing schedulers, process planners, and manufacturing personnel to make sure we get our data right. And so if you'd like to participate in that conversation, or maybe even have your production line mapped out for detailed scheduling to see how you could improve on on-time delivery, detecting bottlenecks, snags, and getting ahead of them, feel free to reach out to us at our email and we will set something up. Thanks, everybody. We'll catch you another time.
Thanks, everyone.